Hello everyone, welcome back. It's been a while since last video where we were going through a course that we didn't finish because of a lot moving around personally and other jobs and then it didn't make it continue. But I definitely want to continue. However, I think before we renew the last course, which is quite intense course, it's a good idea to go through a quick overview of the Flutter. So, if you heard about Flutter, you may have been having some sort of technical background, and that's my assumption. So I won't go through too much detail about what is Flutter and what does it do. But if you want to learn to use Flutter to build a cross-platform, the first place you go, of course, flutter.dev, and this website constantly updating, and which is great, and it's been great to see the big community behind Flutter team working hard to keep updating, and the documentation is phenomenal. It's so much in detail, and even for me, I constantly learning. So it's really good idea to go through, but it can feel like too much, right? Those are all company using Flutter technology, but it's still relatively new, and I found that for something like Python, it takes Python more than a decade to be adopted by a lot of developers. So Flutter is only maybe 4 to 5 years in the market. So it takes time. So yeah, go through to see what it is, and usually people will click get started to get started, and then you will see this screen, and it's a lot. I'll put myself here, and so a lot of people stuck on the first step on deployment, set up a development platform with, and you will have to go through it's a long step. Is it oh yeah, I think you click to install. Yeah, I thought they have a next button or something, but iOS it's changing. But if you go, this is to set up, and the list goes long. What you choose a platform as if you don't have preference, yeah, iOS recommended, yeah, and then you go through all these process. Yeah, we should it should be a separate dedicated session just to go through how to install Flutter, because I already installed Flutter, and so I'm not going through it. But one thing very important is configure the environment, download the Xcode, everything. It's quite a process and easy to get stuck, trust me. And but be patient. There's a lot of online tutorial on how to do it, and you don't have to do everything all at once. Just make it running is good enough for now, and then you will go to just make sure I don't block the screen. Then you go to the write your first Flutter class. Wow, that's very good. So I watched this one. It's absolutely necessary. They changed wow, see, it's a separate tab, so you can go through to each, including set up the Flutter environment. You download the code. What else? I install Flutter SDK. This one should take you back to here. Yes, that's what I guess. But the environment is to one thing you need to pay attention when you set up Flutter is configure the path variable. It's not just download a software and click and do it. You can do it this way, but there's something missing and has to be set up properly, which let me find where they mentioned, because this page is constantly changing. It's these, if for the Xcode configuration, if you don't get it right, firstly, you don't have to, because a lot to do with how to run your app on physical device. It can be tricky. If you just want to run in a virtual environment, you don't have to go through that. But one thing very important is the environment. Where is it? They didn't mention here. Anyway, and maybe I should. Yeah, it's the Flutter environment and the path variable, where you need to make sure the Flutter is in your local path that has been configured. Update. Anyway, so yeah, you should take some time to go through setup Flutter. Then we will go through the report later, and then you go through this very important. This one from how to create. I'm not going to make a video about it because he already have everything you need, very much in detail, and one of the best. Yeah, this one use the provider package English word, and has a very simple navigation. Then inside as there's 2 page, and it even covers responsive design, for a very simple responsive design. How do you handle mobile size versus web size? These are all the code, and these are so when you first create app, it will be like this. Show you how to do how reload, how to build the UI. This is the button unpressed. What's a flash? Oh yeah, crash course in 5 minutes. Yes. Let me see. And handwritten. This is a widget tree. My app, my homepage. I'm just quickly go overview for myself as a review, so that I want to make sure this is a step that everyone should go through, and for me the overview about I didn't miss everything. I didn't miss anything important, so me too need to review to refresh the basics. So app state.get next. This one you change notifier in the provider. This is it's like a view model or controller, whatever you call it in architecture terminology. But basically you want to separate your logic with the UI, so you write how to change the state in a separate class, often in a separate file. So in your UI file, on the button you just call app state.get next. How to get next is in this function in different class. And then you go to next. It makes prettier, where you add a lot of nicer UI, element, decoration, and a card. Card basically a pre-made container that has all the radius, shadows, and you can add a theme, colors. He hasn't centered. Yeah, you should make it centered. Improved accessibility, light, here you add this. Yeah, so everything looks good. You add another center, so you want to center vertically and horizontally. That's why you have this widget. Nice. And it's a lot to go through just for the UI layout. And functionality is when I click a button, you want this to change favorite. So you create, this is a key, business logic, app state to the, so you want to add a list of favorite name into a list. So you create an empty list, then you tap to add a new to the list, add or remove, right? You but these are the local state because we don't persist the data. So that means when you refresh, reopen the app, it's empty. You need to connect backend the database to make the data consistent. And here is the full code, which is it's still a lot of UI spoiler ahead. Okay. Add list, the icon, so you can favorite or border the favorite, so like different icon. So you can do like list is like, click, unlike. Very neat. We want to do something like this. In this one, he add a navigation wheel, something like this. And there's a pre-made widget like this. So yeah, it's the whole thing, the row with one section here, another expand. So the one on the left expand to cover whatever the remaining space is, and this is fixed size. You can adjust the paddings, font size, generator page. These are all color stuff. What's this? What is doing here? State list versus state for widgets. Okay. You should know that. Set state to change state. So select state. Basically here, if you select here this icon home versus the like, it should show a different screen. So how do we do that? That's a change of state. You see, currently the first one is 0. When I tap, I want to change to the next one. This value is 1. The select index became 1, and because this change the state, the look of the screen basically. So we want to set state, otherwise it's not changing. You can also use this with as switch case placeholder. Here he's building. We are not going to memorize all the code and give me a blank of screen. It's still taking me quite a long time to build these things, but the process, the thought the logic is important. What we need to consider, responsiveness very important. So if this run on a mobile screen, it will be different. So here we use layout builder. Yes, but at least you need to know what to use. Here has a constraint. So we say, okay, if the constraint maximum width in the current screen is bigger than 600 pixels, and we do this, right? And then it was extended. Otherwise, we do not extend it, something like that. There's many ways on doing this. I'm very good at responsiveness because I worked a lot on that. But it's a lot of work. And here it builds the favorite page. My eyes not good, so I have to look very close to the screen. So just ignore me. I just want to show my face to prove I'm alive. I'm here. It's not some machine AI going through the code. Yeah. So you can skip these. You don't. And if you are new, you should watch the video, go through one by one, and it will take you probably 2 hours or so. At least 2 hours, I think. Yeah, and to install Flutter setup maybe another 2 or 3 hours. So half a day at least to get to know the basic. Now learn the fundamental. So one of the reasons I'm on this page is because I heard there's a Flutter fundamental course, and Flutter has sorted through. Let me stop the video to find out where it is. Okay, it's this page called Flutter. In docs.flutter.dev got started fundamentals. So this is a newly organized file that I haven't went through, but of course I learned the basics of Flutter, but I would like to go through this with you, and just to make sure that I'm not missing anything important, and also to point out where you need to pay attention. So after setup and after the tutorial, you go here, and then there's several from introduction to Dart, one of the most fascinating growing language, to widget, fundamental, layout, state management. It's all around here, networking and data. Okay, why don't we go through one by one? So Dart, it's most people never heard about it. Every time I tell people ask, oh, what's your programming language do you use? I said Dart. I have to spell D-A-R-T, the O. What is that? Okay. So this is the Dart syntax. It's typical OOP, and small. Okay, if you are confident in your ability to understand program, you can stay. So this is the simple page to go through the index. So you have package, name, latest version, description, and you write to screen. So this is the data model. It's not complete. It's not how to say. We also need to override the hash code equal sign, so it's not equal if the value is the same. But but it's a data model, and then main function as entry point, and here's how you use HTTP to call this function, call this URL of here, and you await HTTP dot get this one. You check if it's not 200. This is not the best way to handle error. Let's get an example. In reality, you want to display on the UI about a dialogue or something, and then you pass a JSON. Here is also not the proper way of doing things, and that's the thing. So all the sample beginner code is done this way, but very soon you will learn it's not a good way. But you get the package anyway, so you can print, you can see the data of here. Okay, but this is to show you the syntax of Dart. So most common feature class with Dart is a type safe. It uses static tab checking to ensure the variable's value always matches the variable's static tab. When defining a class, annotating the member with string is required, but it's often optional due to type inferiors. What does that mean? It just so if here you need to specify it's a string, but if you write final my name equals quote this, the compiler knows it's a string. You don't have to write down it's a string. In the main function in this example, there are many lines and start with final variable name, blah blah. Yes, a type safe, very important. Dart also has built-in sound null safety. It's a very important topic if you are not familiar with. So basically, the type this at the end means the property can be null. The other two member cannot be null. If you say final variable name, final string, it means it cannot be null. It must be some value or empty. If you try to set them to null, you get error. And then the next example is main function, where the initialize code go, it go to lib run app goes here. Perform any quick initialization before calling run app. Although be aware that the widget tree hasn't been created yet. If you want to perform initialization, then takes a while, such as loading data from disk over network. Do it in a way that won't block the main UI thread. So check out the asynchronous programming, the future builder, yes. Defer components. And every stateful widget has an init state method that's called when the widget is created and added to the widget tree. You can override this method. Yes. Yeah, in the code you will understand what does that mean. So basically, if you get data from internet, it's going to be before you can get it, it takes time. So you want to handle all these different states properly. If these features aren't familiar with you, you can bootstrap into Dart page. That's interesting. We probably check this next time. Interesting. Yeah, I read through it already, but not in full detail. here we go into the widget. I just want to see what's the very bare minimum of the Flutter official documentation for introduction for Flutter fundamental, right? So widget. To get started with Flutter, you need to have to be familiar with Dart language, yes, check, and widget, which is building block of Flutter UI. You will continue learning widget. Everything widget is not completely true, but it's mostly true. Widget is an immutable declaration of part of user interface. Very important. Widgets are used to describe all aspects of a user's interface, including physical aspects such as text, button, to layout, like padding or element. You know, like where this website, this text is a widget. This is not just a text, it's a text button. It's a widget, right? And the padding between each is a widget padding. This is probably the icon widget. So I would see widget what you see, including what you don't see. Like in Flutter, the layout is a widget, but it's not that obvious on your eye. For example, this horizontal is maybe a column for each row, right? And here inside is something else. Those are widgets, and all put together. But widget is immutable. It's a very important word, and you will learn why is that. So widgets form a hierarchy based on composition. Each widget is nested inside its parent and can receive content from parent. The structure can reach all the way up to the root. See, from my app is a stateless widget. It's abstract class just to describe what you need to build. Every widget will need to extend this, override the build method. Material widget, which is the root widget. Scaffold is like layout, where you get the app bar like this, right? App bar, the body, center, make sure everything's centered. The default is on the left corner, which is usually not nice. I'm not sure whether they add a builder here. In some cases you need a builder, and in most cases you probably don't need a builder because this is in the build method. And you have a button. So yeah, all these it takes quite a few weeks to learn all these, and you have to go through the hands-on practice to understand how the layout work with each other. See here, my home page got lowered a button. These are the hierarchy, which is super important to be. It matters on how do you get the data. And if data from one widget to another, if you don't know the widget tree, you try to get this data from here, it may not be connected. So it depends, especially if you use provider. Building widget here. Yeah, here's just refactor of separate padded text, and you can reuse widget state. To learn more about Flutter render widget, check out Flutter architecture over. This is a good one. I read this one too. Render widget. This is to tell you what's internally about. In the Flutter, you have embedder, and in the low level here, then talk with the native plugin and packaging stuff. We have an engine that works in platform channel rendering, And in the very top is the Dart framework, and you should go through this separately. Now let's go back on widget state. So the framework introduced you two major classes of widget: stateful, stateless. And these are all, every interview question like to ask you what's the difference on stateful and stateless widget. The definition is not that important. It's not about memorizing, but to understand how do we use this. It's pretty straightforward if you start writing code. Stateful, right? You have a state, a variable that can change. The screen will change. In very simple way, if the screen change in react to external action, then you need a stateful widget to change. Important widget that is you need to know. I know it already. Then here the layout, building user interface with Flutter. See, each has a lot. This is user interface. It's a huge tutorial that gesture detector button stuff in response to layout. Let's see it. It does. Like text input, putting all together. This one, do they have a text field? No, this one is not a text field. Text field basically a line where user can type a value. But yeah, let's go through another one. I already know that. So if you are new, you have to spend all the time to go through all these, understanding the layout. Flutter is a UI toolkit. You will need to spend a lot of time creating layout in Flutter. In this session, you will learn how to build layout with some most common layout widget. You will use Flutter dev tool to understand how Flutter is creating a layout. Finally, you will encounter and debug one of the Flutter's most common layout error and unbounded constraint error. Understand layout. This is also a very important section. The core of Flutter's layout mechanism is widget. So with Flutter, everything is widget, and then things you don't see are also widget, like rows, column, grid. You create layout by composing widget to build more complex one. The diagram to show you 3 icons. This is 3 icons, which is the row. Each row is a column. Each column has a text icon. Good. Constraint is very important. Layout in general sense refers to the size of the widget and their positions on the screen. The size and position of any given widget is constrained by its parent. It can't have any size it wants, and it doesn't decide its own place on the screen. Instead, size and position are determined by conversation between a widget and its parent. There's a very good article about this. It's very important. Very, very important. Like, do they have here? We will go through. They should. Yeah, they probably referred in somewhere. Layout builder. I'm trying to find one very good example. Tutorial maybe not adaptive. It should be layout in Flutter tutorial. Yeah, probably this one. We will see. Let's go one by one. It's probably it's same. So here, if I find out that article, oh, maybe it's here. Screens goes down. Yeah, this is a very good one. You see the widget and talking to his parents. Hey parents, what is my country? We will go through here as a review. Let's first follow the basic structure, and then we go to detail for each, right? So this is still within the fundamentals. Don't if we check each detail, it's going to take a long time. But basically, a widget receives constraints from its parent. A constraint is just a set of 4 doubles: minimum, maximum width, and minimum and maximum height on the screen. If you never created this, never used Flutter, this is very hard to understand. The widget determines what size it should be within those constraints and passes its width and height back to its parent. The parent looks at the size it wants to be and how it should be aligned, and set the widget's position accordingly. Alignment can be set explicitly using a variety of widgets like center, column, row. Box type. In Flutter, widgets are rendered by their underlying render box. So each widget has render box object, and each widget has an element. These objects determine how to handle the constraints they are passed. Load and try to be as big as possible. Center, list view. I have a message. Some widgets, for example, container, vary from tab to tab based on their constructor argument, and loads and try to be a particularly size. What does that mean? Others, for example, rows and columns. Box tab. What does that mean? Oh, sorry, a little bit distracted on the message, but anyway, let's focus. So box type is to like a box, right? And it gives the basic bone, it's like the whole size on how like container or row column layout. And for detail, you have to understand these. We will go through that later. Layout a single widget. I don't know how to explain all these complicated things in here. Use a widget called run bordered image. Yes. So I give you example for this. For example, if we say on the screen we create a text, and usually the text has a default size, let's say 14 or something, then it will be showing on the screen somewhere like Flutter text. And if you want this text to show in the center, you need to wrap with center, and the center become the parent of the text widget of Flutter. So the parent will tell the text where you are. The parent say, you be the center. And if you want this to be very big, this one text is not a good example. Let's say we have a bunch of text, that's the whole paragraph. And to some point, it will not fit on the screen if on the mobile app, right? So you will need the widget, the parent, to tell you how do you render, how do you display to fit in the screen, how big you can be, and so on. You try to be as big as possible, but your parent tell you, no, this is the constraint, that you can only take on the screen. Here is a good example, bordered image. It's basically an image widget with the center to come here, the child property. Oh, interesting. So they default as this cute little dart. So container is very important, one of the most fundamental widget, where it has so many properties, and you can customize how it looks, like padding. So see, padding is one. Padding means this is the image, right? And this is the container. What's the distance between the border and to your image? And we say 16. Yeah. But things can get tricky when you have a lot of the image. And what if you make the screen smaller? It's not going to fit. You get error. Then here, if you want an image with a text, this is column, horizontal. Yeah, these things, if you just go through some fundamental Flutter course to learn these, it's not that complicated. Here you can see you can use different parameter to set the space evenly sweet. It's like this, right? It's very interesting. This is to be in a way horizontally. That's a very common error that you can do. In this case, using expand or flag in the middle. Expand means leaves can take as much as possible to take the full screen. Here, dive to and debug. This is very useful when you develop the layout. A box and tries to be as big as possible. One function useful as an abundant constraint, especially on list view scrolling, and it's easy to have issues. So you need to read. I watched the scrolling list view, very important, so that the page can scroll. And here you have adaptive layout. Yeah, use list view builder. You need to understand what's the difference. Builder versus list view. Builder is more efficient when you have a lot of lists. Adaptive layout. This is Flutter used to create mobile, tablet, desktop, and web app. It's likely you will need to adjust your application to behave differently depending on things like screen size, input device. It referred to as making an app adaptive. and responsive. Yes. Have you ever wondered what's different on adaptive versus responsive? I will see just to mute my notification so then no distraction. Focus on adaptive means your code adaptive to the platform, right? Whenever it's iOS, web, desktop, different. Responsiveness is usually it's about the layout, responsive to the size of the screen. So they address different issues, but we need to address both to make it both adaptive and responsive. And layout builder is very important. And you almost always need this widget. It will tell you the maximum with constraint on a screen on what's the maximum width or height your widget can take. Again, it's very abstract concept to go through here. You will need to understand in the code and make a lot of error, a lot of struggle to understand better. They give you a good example. If it's smaller than 60, you will use mobile layout, otherwise a desktop layout. It will look different. And layout builder, item builder. Here, what's this? Work. Yeah, it's different type of. It just give you like decoration for every second row. You can give a color. Usually I like this way, but not blue. The light gray with white. It makes a nice layout. It's a lot. It takes you a few months to learn the basics. Yeah, but all these are very important. Stack, layout. Good luck to learn all the layout. And then another big important topic, state management, which will be our main focus later on. Here, every stateful widget has a state, and in Flutter, the way it's made is with this is a native inherited widget. Then we'll get data. Your listener both notify, use view model, model view model, manage state in your Flutter. This video shows how to use this. Because we will mainly use Riverpod. Let me see which video is that.
Let's pick up where we left off last time with Fitz.
Oh.
We open up the app, check some boxes, and look at that. Our app state's still there. The boxes are able to be checked and unchecked. Great. But wait, the progress bar at the top, it's not changing regardless of the boxes that I've checked off. What gives? In the last episode, Fitz talked about how Flutter widgets are immutable. They don't change as we're using them in our app. They aren't part of an app, but they describe exactly how to build an app, like a recipe for building a cake. Then came the idea of app state, any data that would determine how our app's UI appears when users interact with the app. The stateless task items were converted into stateful widgets, and state was introduced to our exploration planner app. So we tried to run our app and check off a few boxes, but just as before, the progress bar at the top isn't, progressing. Taking a look at the code, we can see why. The progress bar doesn't have any state attached. The state for each checkbox is independently stored within each task item. How does the progress bar know about those task item states? In other words, how does the widget over there get access to the state that's stored over here? The answer is it doesn't yet. And that's where state management comes in. If state is the data that determines our app's UI, then state management is how we organize our app to most effectively access state and share it across widgets. Now, before we continue, I want to acknowledge that state management is a very hot topic in the dev community, regardless of framework. There's always many solutions available, and everyone seems to have the one that works best for them. State management has two goals. One, provide access to data, and two, tell widgets that they need to be redrawn when the data changes. State management is the guardrail layer in between that gives us the ability to do both of those things. That's it. What's the best state management solution for Flutter? Well, it depends. There isn't one single best option. There are many options available for state management in Flutter, and at the end of the day, you'll probably be happy with just about any of the popular libraries. If you're feeling adventurous, try out a few of them and decide what works best for you and your projects. Due to time constraints, we'll only be touching on one of Flutter's many state management solutions in this video. For the progress bar to know about the task item states, we'll want to lift the task item states up in the widget tree so that the progress bar has access to the task item state. Enough talking, let's get some state management into our app by adding the Flutter Riverpod package to our app.
Yay, Flutter
Riverpod is one of the many state management packages available for Flutter. Riverpod is built on the premise of having providers, or an object that encapsulates a piece of state, also known as data, and allows listening to that state. And consumers, which are objects that allow developers to interact with and read from providers. Instead of storing each task state within the task item, we can give it to a provider that we've called task provider to manage its state. Specifically, we're using a state notifier provider, which consumers can listen to. It's Riverpod's recommended solution for managing state, which may change in reaction to a user interaction. Perfect for our task items. When initializing a provider, we gave it a list of tasks, along with a task notifier, which is used to allow the UI to modify state. From there, we'll go to our progress and task list widgets and convert them from stateless and stateful widgets into consumer widgets. Consumer widgets are a special kind of stateful widget that lets you access providers by giving you access to this ref object. Within the consumer widgets, we can now watch the task provider for any change in the task state. Then whenever there's a change in state, that widget and all of its children will get rebuilt to reflect our new app state. Plus, because the provider is declared as a global object, other widgets in your app will also have access to the provider and task state. Now, whenever we check a checkbox, we'll read from our task provider notifier and toggle the task. So what else has changed in our app? Well, we've introduced a task class to make it easier to keep track of individual tasks. We added a task notifier so that UI interactions can modify our task state. We also introduced Riverpod to manage state, which means instead of using the set state syntax, we use slightly different syntax to access the state stored in our provider.
So here's the key. With the read this provider notifier toggle and unkeying the value.
We also wrapped our entire app in a provider scope, a widget that stores all of our providers. Plus, due to our task list being stored as state with the provider, our task list build code is significantly more condensed. We now iterate through the list of tasks instead of hard coding each task item. The data architecture for our app has been changed with the introduction of Riverpod. State has been moved out of the widget to our provider, but that's it. Aside from that, the recipes for each widget remain the same. Now that we've gotten our exploration planner working, in the next episode, we'll take a look at how we can make our exploration planner app look better. See you over there.
Okay, so if you were very new to how Flutter manages the app, and if you were very new to what is Riverpod, how does it work, the video could be a little bit too fast. For me, it's okay because I understand. I spent a lot of time to learn the Riverpod and what's the difference between Riverpod and the provider, all the different kind of provider stuff. So, but in short, it's a good video, but it can be too quick if you just watch video like that. You have to spend several hours to try on your local environment with the code and do it. that's a challenge. But here is not. Here is good. Here is this code is how what you see when you first run the Flutter. They give you a sample code, and you need to understand why we are using a state management package like Riverboard to change the value instead of this way. See here it said encapsulation. The widget that use my counter has no visibility into underlying count variable and no means to access or change it. Object left circle with this object and its count variable. This is the circle where it's moved from screen. Yeah, these are very good article. So there's app state and ephemeral state. Ephemeral state like a local state, like a small widget change. App state is more like the whole structure. I think I read this one before. You see, yeah, it's the state you can turn in a single widget. Depending on this is a simple page, so the widget can be just the bottom bar to change. And the app state is not ephemeral that you want to share. Yeah, it's a state that you want to share in different part of the app. In a typical shopping app, where in shopping page you add the item, right? And then in another page of your chart, the chart need to know how much item you added. That's those are app state. Yeah, so and with the app state, when you want to work from one class to another to talk with each other, you will need to use when ask react set state versus redux floor. Yes, the rule of thumb is do whatever is less awkward. See, that's very good. So there's no best way. It's a way that, yeah, if you are completely new, you need to learn all the different way and choose the one that you feel comfortable, or choose the most popular one maybe. We will go back to, where are we? Here, state management. So read, leave, and share state between widgets, update and listen. So one widget listen to the change of another widget, so it will update. In the section explore how you can effectively share state between different widgets. So use widget constructor, prop grading in other, prop grading. Yeah, this is like passing the parameter from one class to another. It's going to be problematic when it's getting very big. And then use inherited widget similar like a provider package, or use a callback to notify parent widget. You really need how to say the code example and try to understand this better. Using widget constructor. See, this is like a constructor. You see my class take this parameter, and this class would not have the value. The value is passed when you construct this class. This makes it obvious for other user of your widget to know. Yes, so this is the way. So counter will be outside of my counter, like here. These are the same variable. Using inherited, manually passing data down the widget tree can be verbose and causing unwanted border code. So Flutter provide inherited widget down the hood to access data. Extend my state, extend list. Yeah, people don't use this. This is also not good to scale, but this is good to understand the fundamental. See, you create this data and you say off build method, build content. You need to write something like this. For every state change, you need to write all these, and then you see my home screen data. See, my state is here. My state is a static method dot of context. The context tells you like the position of the widget. So every widget has a context dot data. Where do you get dot of widget is the state dot data here. You can use callbacks where you build a tab of widget. Optionally, you can build your own tab for this function, and then you create a class, my counter. For example, this widget may handle unpressed callback, call unchanged. We get dot unchanged. What are them? Here callback. See, this it's passing a function variable to pass as a parameter to this. So when you construct this, you pass by how do we change this like this. Dive deeper. Architecture overview pro. Oh, this is a very good video. Programmatic state management, which I watched. Then it's they use provider. The very 2019 video inherited widget, a guide to provider shopper for sample. Provider counter. Architecture overview. I'm not sure if I read this one. It's here. We will go back to it. This is about constraint. I don't want to spend too much time on layout and constraint for now. Use listenable. You can use change noticeable, value noticeable. Yeah, this is also Flutter internally on how do you change like encapsulate the business logic state change into a separate class outside your UI widget to how do you change your state using the change notifier. And then pass to listenable builder to ensure that the subtree returned by the builder function, and then on the column you do like this. You have a listenable builder to listen this counter notifier, which is basically here. You need to write something to get this, and then counter notifier dot count dot get dot count here, and counter notifier dot increment. You call this function. You have value notifier, change notifier. Yeah. Value notifier is simple. It does not have logic. It's just one value change. simple version of change notifier for a single stored value. For example, let's see weather app with weather data or temperature. For now, it's just one temperature. If it changes, you don't need to calculate, or user does not need to manually change this value. That way we use value listenable builder. Oh, this is listenable builder. It's different, you see. Value listenable builder, and then you have a builder. It's a similar syntax. Using MVVM for the view model. So basically, this is like your view model. This is view model. The change notifier. This is the view model, right? This is your model. Oh no, this is the view on the UI. Define the model. This is the model. You can define the model like this. This is to get. Oh, I don't know this website. Oh, it's a simple. It's real. http.com. Yeah, it's just example. Just example to get how do you do. But we have better way of how to work with future value, how to interact with any network data, handle the error, loading, etc. And it also mentioned about other way to the model doesn't use any responsible here, immutable checkout package freeze the build collection. That's to say that, and when you create the model, this is very simplified. You should make the data model as immutable like this. Defining the view model, see the view model use the change notifier to define like this. Innate, using try and catch to show the error message. The downside is it's easy to forget about this line of code. Notify listeners. If you remove this, the compiler will not complain, but the code will not work. So, and then here is the function to call increment. Counter view model. Defining the view with listenable builder, same as earlier. You see, it's just more. That's it. Repository architecture. Here is the article list of state management approach with list. Let's quick check out what's the list about. I went through list many times. It talks about how the difference about each Redux. A big section about Redux. Animation management with Redux. Flutter-related, because Redux is very popular. In my company, we use Redux as well. Like I will release myself later on. Flutter plus Redux, how to make a shopping rate. A state container approach familiar to many web developers. So that's why people like to use the same thing to apply to Flutter. There are so many video Pythons with Redux, Flutter Redux. Well, Fish Redux is assembled Flutter application framework based on reader state management, but they build different blogs is super popular. Blogs, I'm happy they listed provider first because this is like very basic, and it works with the Flutter. It's like wrapper on inherited widget, and then I'm happy they listed Riverpod on the top. Goon package? I never heard about that. A lightweight modern statement library, focusing, similar to Flutter's built-in statement. Then you have Redux, building a large Flutter array Redux, async Redux without boolean. Oh, there's so many. Blogs is very important, very familiar with stream and observables, reactive programming. Riverpod has some similarity with blog. Again, this is gated. A service locator based on state management and doesn't need a build content, which can be strange. I would not recommend using this one. MoX Dart board. What is that? Modular feature management framework. Dartboard is designed to help encapsulate isolate features. GetX. Oh yeah, GetX different with Get8. That's very easy to misuse. Understand. This is different. Get8 is not bad. It's just a service locator. But the GetX, you see they put it it's a simplified reactive state management solution. Yeah, don't use this one. State rebuilder. I'm just curious to see, are they still having this fancy? Yeah, see, they made this very fancy look about number one, most like blah blah. It's quite a lot to. What is this? It's a blog. I don't know. Wow, it's keep growing, so many. We don't need to know all, right? Architecture samples. This is a good one. It gives you a sense about how do we use all these lift state up, inherited. I see. And here's another. You see, we go from here and then opened up so many sub tabs, and we still haven't go through it. But I think this is a good page where we can see for the same app how using different library the code can be different. Vanilla lifting state up, that's very interesting. It's very basic, but it's important to understand, right? Is this on GitHub? It has the code, so 5 years ago. Good, wow. Anyway, main.dart. I'm not going through the details for this for now, but it's good to have this saved somewhere so you can refer to. And here's architecture overview. I think it's very important as well. We went through this page a little bit, and then here is for our app. Reactive user interface. Flutter is a reactive declarative UI framework. The model is inspired by work that come from Facebook for their own React framework, which include rethinking many traditional design principles. And widget, as mentioned, Flutter emphasizes here widget composition, building widget state. We talk about it. Yeah, these are very good framed. The widget hierarchy or the widget tree rendering from user input to GPU. From widget to element, we are digging deep inside the Flutter. So here, Flutter 3.10 set impeller as a default rendering engine on iOS. So this is on the rendering. How do we pen on the screen and the composition? So when Flutter needs to render this fragment, it calls build method, which rebuilds a subtree of widgets, then renders UI based on the current app state. During this progress, the build method can introduce a new widget as necessary based on its state. As an example, in the preceding code fragment, containers have colors and child properties. From looking at the source code for a container, you can see that if a color is not null, it inserts this color box. Yes. Correspondingly, the image and the text widget may insert child widgets such as raw image and rich text using the build process. The eventual widget hierarchy may therefore be deeper than what the code represents, as in the case. This is so each widget under the hood. There's another element: image based on raw image, text based on rich text. So each widget here, each widget corresponding to the element tree. This is important to know. This explains why when you examine the tree through a debug tool such as Flutter Inspector, part of the Flutter Dev tool, you might see a structure that is considerably deeper than what's in your original code. During the build frame, Flutter translates the widget expressed in code into a corresponding element tree with one element for every widget. Each element represents a specific instance of a widget in a given location of the tree. Hierarchically, there are two basic types of elements. So we have component element, a host for other element, and render object element, which is an element that particularly in the layout or pen frame, like this one. Render object elements are an intermediary between the rigid analog and the underlying render object. So there's another component for the render object, which we will come later. So the element for any widget can be referenced through the build context, which is a handle to the location of the widget. That's very important concept. That's why every widget has a build context, and this is the context of a function call, such as theme.ofContext, and is supplied by to the build method as a parameter. Because widgets are immutable, no matter it's stateful or stateless, the widget itself is immutable. When we need to change the widget, we destroy it and we rebuild a new one, different one, including the parent-child relationship between the nodes. Any change to the widget tree, such as a change from text A to text B in the preceding example, finish my drink, causing a new set of widget objects to be written, but that doesn't mean the underlying representation must be rebuilt. The element tree is persistent from frame to frame and therefore plays a crucial performance role, allowing Flutter to act as if the widget hierarchy is fully disposable while catching its underlying representation, but only walking through the widget then changed. Flutter can rebuild just the part of the element tree that requires the reconfiguration, layout, and re-rendering. So here it tells you very deep on how things work internally. It would be rare application that grew only a single widget. An important part of any UI framework is therefore the ability to efficiently lay out a hierarchy of widgets, determine the size and the position of each element before they are rendered on the screen. These are very important. The base class for every node in the random tree is the render object, which defines an abstract model for layout and painting. This is extremely general. It does not commit to a fixed number of dimensions or even a Cartesian coordinate system. By this example of a polar coordinate system, each render object knows its parent but knows little about its children other than how to visit them and their constraints. The This provide render object with sufficient abstract to be able to handle a variety of use cases during the build phase. Flutter creates or update an object. I read because I think I don't understand this very well. I kind of know, but not really. So it's a lot about how Flutter works internally. Then you mean don't have to know, especially as beginner. But when you have worked for several years about it, you really need to know this. I'm curious on how they frame. I watched a couple of videos about this and other articles, but still, it's good to refresh the memory. And also, if you are in a job interview, or someone asks you to test how deep you understand the Flutter, you will talk about it, right? You will show you dive deep into the source code. So during the build phase, Flutter create or update an object that inherits from render object for each. This inherit from here for each render object element. In the element tree, render objects are primaries. Render paragraph, render text, render image, applies to a transformation before paint is killed, like this. So most Flutter widgets are rendered by an object that inherits from render object subclass, which represents a render object of fixed size in a 2D Cartesian space. Render box provides the basis of a box constraint model, establishing a minimum and maximum width and height for each widget to be rendered. This is to walk the render. To perform layout, Flutter walks the render tree in a depth first traversal and passes downside constraint from parent to child. In determining its size, the child must respect constraint given to it by its parent. Children respond by passing up a size to their parent object within the constraints the parent established. So size goes down, goes out, constraint goes down. Yeah, this is again about layout, about how relationship for the widget to work. We will go through the code example, then you will understand better. This is very dry, very boring. So at the end of the single walk through the tree, every object has a defined size within its parent constraint, like a home. Your home is this big. You can't put a bed bigger than the home, right? And ready to be painted. The box constraint model is very powerful as a way to lay out objects in an ON time. Very important computer science concept. Yeah. ON. Parents can dictate the size of a child object by setting maximum and minimum constraint to the same value. For example, the topmost render object in a phone app constraint to its child will be the size of the screen. Children can choose how to use the space For example, they might just center whatever they want to render within a dictated constraint. A parent can dictate the child's width but give the child flexibility over height, or dictate height but offer flexibility over the width. In real-world example, is a flow text which might have to fit horizontal constraint but very vertical depending on the quantity of the text. This model works even when a child object needs to know how much space it has available to decide how it will render its content by using a layout builder widget. The child's object can examine the passed down constraint and use laws to determine how it will use them. For example, we see this a lot. You will use a lot about this one, and it's good to write your own refactor code so that every screen is consistent to have the same constraint. The more information you understand constraint, the root of all render object is the render view, which represents the total output of the render tree. When the platform demands a new frame be rendered, for example, because of a thing upload. Anyway, platform embedding. As we see, rather than being translated into the equivalent OS widget, Flutter user interface are built, laid out, composed, and painted by Flutter itself. The mechanism for obtaining the texture and participating in the app life cycle of the underlying operation team system stable API application banner interface, then provide a platform embedder with a way to set up and use Flutter. The platform embedder is a native OS application that hosts all Flutter content and acts as a glue between the host operating system and Flutter. When you start a Flutter app, the embedder provides the entry point, initialize the Flutter engine, often threads for UI, input. Flutter includes platform embedder for Android OS, Windows, Mac OS, Linux. You can create your custom platform embedder. If we need to do, this is good results to come through Flutter cast. I will start it here first and read later. This is old, but it integrating with other code. For Flutter provides a variety of its mechanism API, whether you access code or API written in a language like Kotlin or Swift, calling a native C-based API, embedding native control in a Flutter app, or embedding Flutter in an existing application. platform channel for mobile and desktop app. Flutter allows you to call into custom code through a platform channel, which is a mechanism for communicating between that code and platform-specific code. By creating a common channel, you can send and receive message between Dart. Okay. Serialize from Dart type like a map into a standard format, deserialize into equivalent like Kotlin, Swift, such as dictionary, Kotlin and hash map. Okay. So custom Dart code goes through Flutter framework, method channel, binary message into different Flutter engine, Android shell, iOS shell for Flutter view controller called Flutter method channel with custom iOS code. We almost finished this section. These are important in the sense working with native app. A lot of apps, they are built with iOS. It's either they want to have a certain feature made with Flutter mixed with their existing iOS app instead of creating a new app from scratch, or it can be a new Flutter app but with some customized solution to deal with native app. So then you will need to dive deep into how this is done. Following the short platform channel example of a Dart call to a receiving event handler in Kotlin or Swift. So Dart said it will call this, Kotlin will do this, and iOS with Swift. Further example of using platform channel including example on desktop, foreign function interface. For C-based API, including those that can be generated code like written in modern language like Rust or Go, Dart provides a direct mechanism for binding native code using this library. FFI, foreign function interface model, can be considerably faster than platform channel because no serialization is required to pass data. Instead, the Dart runtime provides the ability to allocate memory on the heap that is backended by a Dart object and make calls to statically or dynamically link the library. FFI is available for all platforms other than web, where JS, interlibrary, and package web serve a similar purpose. To use FFI, you create a tab of each Dart and unmanaged method. So this is how do you work. I have not tried this, but it's good to know what's out there. So when we need to understand to work with it, this is the documentation. Let's see what's this. Rendering native control in Flutter, because Flutter content is drawn to a texture and its widget tree is entirely internal. there's no place for something like an Android view to exist within internal model. What's this of? So here Flutter solves this by introducing platform view widget like Android view, UI kit view to let you embed this kind of content on each platform. Platform view can be integrated with other a good example is for the Google Map Flutter plugin. So that's how they do hosting Flutter content in a parent app. Yeah, this is to a preceding scenario is embedding a Flutter widget in an existing iOS and Android app as described earlier. A newly created Flutter app running on mobile device is hosted in an Android activity or iOS UI view controller. Flutter content can be embedded into an existing Android or iOS app using the same embedding API. The Flutter module contemplate is designed for easy embedding. You can either embed it as a source dependency using Gradle Xcode build definition. You can compile it into lead framework. The Flutter engine, this is and takes a short. I'm not sure. Yeah, this is to add a certain Flutter widget into existing, and you need to dig deep into how to do it. This is just very high level overview. Flutter web support. Web is important. And it's getting better, right? So, however, Flutter engine written in C is designed to interface with the underlying operating system rather than web browser. A different approach is therefore required. So on the web, Flutter provides an re-implementation of the engine on top of standard browser API. We currently have two options for rendering Flutter content on the web: HTML and WebGL. In HTML module, Flutter use HTML to render. Flutter use a version of SKIA compiled to WebAssembly called CanvasKit, where HTML module offer the best code size characteristics. CanvasKit provides the fastest path to the browser's graphic stack and offers somewhat higher graphic with native. Yeah. Okay. This is the web framework. Perhaps most notable difference component to other platforms on which Flutter runs is that there's no need for Flutter to provide a Dart runtime. Instead, Flutter framework, along with any code you write, is compiled to JavaScript. It's also worthy to note that Dart has very few language thematic differences across its modules. The just-in-time versus ahead of time, native versus web compilation, and most developers will never write a line of code that runs into such a difference. During development time, Flutter Web used Dart Dev, a compiler that support incremental compilation and therefore allow the hot restart, although not currently support hot reload on the web. Conversely, when you are ready to create a production app for Flutter Web, the Dart2JS Dart highly optimized production JavaScript compiler is used, packaging the Flutter core and framework along with your application into a minified source file that can be deployed to any web server. Code can be can be offered into a single file. Yeah. Inside Flutter white paper, what's inside is here. I read these. Sometimes I read, then I forgot. That's why I'm reading again. These are more advanced topic. As a beginner, you don't have to go through, but at some point, you need to read through, although you may not understand every single word, but slowly, it takes time to understand all. And this is very important on one of the most important article on understanding constraint, and you have to go through this. It's a I already went through this multi-times. So do we still have more building modes? This is important to know as well. The debug, profile, and release mode. How reload works only in debug mode. By default, Flutter run compiles in debug mode. The build is not minified and tree shaking has not been performed. The app is compiled with this compiler for easy debugging. So debug mode means assertion are enabled. Service extension are enabled. Compilation is optimized. Why my video suddenly went this? Anyway, so we're almost done for this overview of Flutter. So your IDE support this mode, and your Studio run, debug, as well. Yes. Simulator only in debug mode. Application performance can be junky in debug mode. Yes. Measuring performance in profile is profile mode on actual device. And then you have release mode. So the release mode for deploying app when you want maximum optimization and minimum footprint size. Assertion, disable debugging information. Yeah, disable compilation is optimized for fast startup, small package size. For the web, it's also different. We use Dart. I don't mean to open it. Dart2JS compiler for performance, and you will use this to compile to release mode. The IDE support this mode, the run option, and a rectangle, going wrong button, you can compile specific type Flutter build something. Profile for some debugging ability is maintained enough to profile your app's performance. Profile mode is disabled on the emulator. It must be in a physical device. On mobile, profile is similar to release mode with some differences. On the web, there's more differences. Common Flutter error. Render reacts overflow. How you may run into this error? Yes. How to fix? You add this. These are all the common layout error. Render box are not laid out. Vertical view, unbounded. How to fix? Input decorator cannot have. Yes. Incorrect parent data. Set state code during the build. Don't do this. Yes. The code doesn't make what's going on here. Anyway, just show my photo. It's okay. It's almost done. The scroller. This is also a very common mistake on the scroller. This is, yeah. I should watch this again. I think I watched that one. This one is about how to fix here first screen. This is about navigation. Navigation to go to another one to pop my dialog. So when multiple scrolling widget like this view appear on screen at the same time, then more likely on web or desktop than a mobile app, since it rarely encounters primary scroll. Yeah, handle errors. There's a lot of way on handle errors, and we will learn in details how do we code error. This is one of the way. It's very complicated. Report error to service. Yes. So let me save this page. I think this is useful to come back someday for Flutter samples, but not today because we have a lot to do. See, we went through this and we opened a lot more. See, and I will not go deep into here because this is still a UI button or a text field, on what a user do, a form, and chip, drop down, slider, toggle between the values, switch radio, checkbox, switch. They have a new one. Checkbox list tail and switch list tail. like this. Select, oh yeah, the dip picker, time picker, swipe, slide. These are all the user handling, user input, right? I would say including the scrolling. And then, no, these are also essential. The app need data. And how do you do that? There's many ways. Local data catching. Riverport automatically catch the data. But if you want absolute persistent offline, you need a different approach, like create a database or something. Otherwise, or shared preference, yeah, to save some simple value. For example, the user preference. Do I prefer the dark mode or light mode? Then you can use the shared preference. Catching image is very important. There's a library to do that. Okay, that's all for today. Oh, too bad you can't see me for now. No. Okay. The video is gone somehow, but I just want to say bye. They don't render my page. Hey, here. Yeah, okay. That's all for today to go through the Flutter fundamentals. And as you can see, it's very comprehensive documentation, which can be dry and not easy to understand, but still this is important. And on Android code, we also have, this is a free one. It's a very quick goes over for the Flutter basics, which I will go through for the next session. Let's take a break. Okay, bye bye.